Self, and thank you. Before saying anything, thank you very much for joining this demo. Okay, so this particular demo is going to talk. In this demo, we are going to talk mostly about the big data and the general use cases, or the how it is used basically, and how it is connected to Hadoop, and how big data and Hadoop are connected. Right. So basically, the general overview and some technicalities of this. Okay, so let me just begin with my introduction. I am Sathya, and I have 13 plus years of experience, and I'm big data certified, sorry, Hadoop certified developer as well as administrator. And then on big data, I have around 4 years of experience, and in teaching, it is close to 2.5 years. Okay, and this is going to be my 38th batch. Yes, and till now I've trained at least 250 people. Okay, it is much more than that. Okay, so let me just start. Give me 1 second. Fine. So before going into big data, yes, so we are here to understand what is big data and all. Yes, so before going into that, so let us talk something about the data. Right? So what is data? Right? Data could be anything, actually, anything which can be collectible, right? So which we can collect and stored in digital form, right? So we call it data right now. And data could be there in multiple forms. Data could be there mostly people will get this data in the form of tables, right? So which is there in your databases, and that is not the only data which is available, obviously. So we have data in Word, PDF files, text-based files, and within text-based we have multiple formats like XML, JSON, and RTF. So a lot of formats are there, and even audio, video, all these formats are data, right? And how much data we are talking about? If you just look at some numbers here, right, you just see everything in terms of petabytes. Obviously, not all the companies who are working on big data are working on petabytes. Okay, so it could be hundreds of terabytes. Okay, 2 petabytes. Okay, but slowly almost all these companies would move into petabytes of data. And here we have couple of things actually within big data. The big data is basically defined as 3 V's usually. Okay, and some people call it as 4 V's as well. Okay, that is a different thing which we will talk at later point of time when we. Okay, but here volume, velocity. What is volume and what is velocity? Right. So volume is the amount of data which you already have, and the velocity is the amount of data which is flowing in periodically, incremental data. Okay, so if velocity is high, though your volume is less, if velocity is high, obviously it is going to add up or bring your volume to be very big number. Okay, even if you have very big volume and you have less velocity as well, still it is the problem of storage, right? So basically, so these two are about storage, right? The amount of data, storing the data. And this particular thing, variety, so dealing with variety of data is not something new. Okay, people across the world, many companies are already dealing with with variety of data, right? XML, JSON, or RDF, or they have their own formats of data. In fact, okay, if not this, they have their own style of. They're working with it, obviously. So why are we talking about variety at this point of time, and we are saying it can handle structured, unstructured data as well? Can't we handle it right now? We are handling it right now. Okay, people are processing video files, audio files, all these people are already processing it. But what this big data in terms of variety is adding is the speed at which you can do things. So basically, processing all this variety of data is time consuming process. Okay, So that can be done very fast. So ultimately we are talking about two problems. One is storage and the other one is computation. There are only two problems which IT world is facing, obviously. I'm saying about IT side of it. There is storage and computation. You want to store unlimited data and you want to process it as soon as possible. That's it. Okay. So big data is basically a very broad term, okay, which describes or which actually talks about all these technologies which are trying to store huge amount of data or which is going to give you the power of processing where you can process the data very fast. Again, huge amount of data. So any such technology is basically part of big data. So big data is a very broad term and it has another definition as well, or the generally accepted term basically is the technology or something which can handle the data which cannot be handled in your traditional systems, which can give a better power of computation, obviously. Okay, so those technologies are called big data technologies. That's it. Okay, there is no other thing for that. Okay. And now moving on to the next slide. Basically, this slide is just to show about how basically the world of data is increasing, right? So if you see here, basically it's growing very huge actually. It's 2012, and if you see that graph, then it grows exponentially, obviously. Okay. And generally accepted number is every 1.2 years data is doubling. Okay, so it is very general. It's not, it may not be applicable specifically for your company, but generally that is what the scenario is. Okay, and if you see here, this particular company called EMC Square, which actually shares their analysis on various technologies and the trends, they actually mention that the data from 2009 to 2020 is going to grow by 50 folds, that is 50 times. So we are right now somewhere here, probably you can say here. So there is a huge data surge which is expected right now. And this is about variety. So if you see, there are two bars in this. One is red or brick red and the other one is blue, and this red color signifies unstructured data. Okay, so basically the various analyses say at least 80% of the data which companies are working with are unstructured data. Obviously they are actually making it structured first and then they are processing it. That's a different case, but the first form of data which they get is in unstructured form. Okay, what they'll do with that is the next part. Okay, I think someone. Okay, Vision Reddy says he's not able to hear. Guys, you are able to hear me? Anyone else has any problem? Such problem? Guys, you are able to hear me? I'm fine. Okay, you don't have problem. Okay, Vision, can you please check your audio? Okay, thanks, guys. Okay, let me just continue. That was about variety, and this is the various comments made by big analysis companies like McKinsey, Gartner, and Forrest Research, and they say that big data is going to play a very crucial role in their business, obviously analytics, and they specifically mention about Hadoop. Now I think it's a good time where we can talk about the connection between Hadoop and big data. As I said, big data is a very broad term which describes about all these technologies, right? Which are trying to solve the storage and computation problem, and there are around 200 to 250 technologies which comes and which can be called big data technologies. But everything has most of these technologies has been specifically built to solve particular problem which that company is actually facing. Okay, but Hadoop is something, out of all these technologies, Hadoop has become leader of all these technologies, and it has emerged to be used is most widely. Okay, so it's most widely accepted big data technology, and it can do a lot more than what other technologies can do, which we will see, which we will discuss as we move on. Okay, and so Hadoop is one such big data technology which is widely accepted and which has emerged as obvious leader of big data stack, and it has emerged to that extent where people, whenever someone says big data, automatically people say, oh, okay, Hadoop. Okay, that is how famous it is, obviously. Okay, now coming to, okay, fine, so we are talking about data and all this stuff, but where this data is coming from? Why do I need it? First of all, right? So let us take a very small example of Google search engine. Obviously, Google search engine is the pioneer of big data technologies. When no other guys were actually using, Google has already been using it. Okay, that's a different thing. Now, Google, if you look at this very simple use case of Google, Google actually share their analysis. Okay, share their analysis like, so and so person is the most popular person in the world, or so and so person is the most popular person in India or Andhra Pradesh. He is the most, how this popularity is decided? Based on the number of searches which happen. Okay, based on what people are interested in, right? So based on that, popularity is decided, obvious. Now, this obviously shows that they are tracking what you search. It's not just you are consuming the data, you are also generating some data, right? So if you take, how many times, probably an average user might be using Google search bar. How many times? 30 times? So at least I do that. When I'm working, I use it at least for 30 days in a day, 30 times in a day. Probably that, it's very commonly, accepted number. So I am taking a bare minimum. Out of 7 billion people in this world, I am saying only 1 million people are using Google search. Okay, even if only 1 million people use Google search, then it is 30 searches and 30 million records are generated for Google. 30 million in a day with your location. Okay, if possible your IP, if possible all the details. Okay, and if you take for a month, it will become 900 million, and if you take quarterly, that will become into 3. That's quite a big number actually. It's not a small number, but I'm taking a very small case. Now obviously Google is working with n number of other things. Okay, so now we understand why Google is dependent on such big data technologies. But we don't understand why every other company has to use it. Right? Okay, Google is such a big company, they have such a need, they are using it. So if you take the example of the retail companies, okay, like Netflix or Amazon, it could be anything, video, or it could be a normal site wherein you sell various products, right? It could be anything. In any of these sites, if you look at this, you would see some kind of recommendation somewhere on the right, top, left, somewhere. Okay, So how they are actually able to generate such recommendations so accurately, right? So obviously, whenever you search for something, you see that okay, somewhere on the top or somewhere, right? That is recommended. Basically, next time when you log in, right, after 2 days or 3 days, when you log in, you will see that such recommendation. Basically, these guys are tracking each and every activity which you do. Whatever you search in their site, they want to know about it. When you click on some product, they want to know about it. When you click on it, add to cart, and you don't do anything, they want to know about it. Even if you had done it 1 year back, they want to have that retained. That shows that at some point of time, somewhere, you are actually interested in that product. Okay, that could link to some other products. That is a different thing. But they want to store all this information in some other form, obviously. Okay. So millions of customers are there, and they are doing tens of activities in a day. So that will lead to tens of millions of records of data actually, right? So now you can imagine they want to store not just for 1 day. As I said, at least Dell wants to store it for 1 year or 1.5 years. Okay. So various companies have their own timelines and limit depending on how much data they are interested in and how much old data they want to retain. But they want to retain the data. And every activity which user does, they want to retain it. Okay. And ultimately, they want to do an analysis. They want to do this analysis of which user is interested in which product, and they want to recommend that to particular user. And that obviously, as I said, terabytes of log data is actually generated by these servers, and they want to retain it. Terabytes in a day. And then obviously similar cases there in various other domains. Okay, various others with various other verticals or horizontal, whatever people call. Okay, they're not worried about that. So all these companies, every guy. So what they want to do? Obviously, they were till now they were actually generating some reports. Okay, reporting, and they do some analysis, basic analysis, and they also do monitoring, and they want to do prediction as well with the customer. So with predictive analytics, the help of predictive analytics. So now why we are talking about predictive, or what is analytics and big data? Why people are talking about big data analytics? Was there no analytics before big data? Has big data created analytics? No. Analytics is a set of algorithms which can be used on a normal data set as well. Why do we need big data for that? I'll tell you the simple fund of analytics. Analytics basically say a very simple thing. A simple algorithm applied on a very huge data set can give very good results rather than applying a very complex algorithm on limited data set. So the point is, the more you know about the customer, the more data you know about the customer, the better you can actually analyze it. It's very simple. It's common sense actually. If you take a person whom you know for some time, right, for 6 months, then you can predict him better than the person you know about probably like 1 month, or you met him only for once or twice, right? Obviously, it's a very similar thing. Of course, the example is crude, I accept that, but it is very relevant. Fine. So now that is how big data and analytics both are related. Okay, basically now most of these technologies, including Hadoop, can actually process the text data or audio and video and images. All this data can be processed. But to do that, you need to have your own algorithm, obviously. Okay, and working with audio and video files is not a joke. Okay, mostly companies have their own patented algorithms to do such thing. Okay, very few companies actually work on such speech synthesis or speech recognition or video synthesis or video analysis. Okay, so most of these other companies are actually dealing with text-based unstructured data. Text-based unstructured data. As I said, the data like JSON, XML, or a flat file which has its own structure, right? So now coming to Hadoop. Hadoop is basically a open source software which is free of cost, right? Open source, free of cost. You don't have to pay a single penny to anyone. For reliable. How it is reliable? So let me just open Paint. I'm just freezing the screen, guys. Let me just open the Paint and then let me unfreeze it. Okay, can anyone confirm you're able to view my screen? Yes. Okay. Okay, thank you, guys. And guys, one more thing is you are actually kept on mute, right? So that would be only for today's session. It is in demonstration. But in our classes, once we start our classes, you will not be on mute. Okay. Fine. Now coming to this part, Hadoop basically works on multiple systems. It's not like a very big single machine. It's a set of small machines. We call them as commodity hardware. Okay. It's a chain of small machines. So you have a lot of machines. You can have hundreds and thousands of machines connected together over network. And each of these machines connected in the network is called a node, and this set of machines is called cluster. Okay, it's very simple. In Hadoop, when you have this data set A, that data set is actually stored 3 times by default in various systems. Then guys, if someone knows details about this, I'm not mentioning anything about it. I'm just saying it's a data set A. I'm not saying whether it's a file or folder or what it is basically. I'm just saying a data set A. Okay. So this data set is actually repeated 3 times on various systems. And if one of the machine is down, then Hadoop will automatically replicate this data A on another machine and make sure that this data is available the configured number of times. So you can actually configure a data set to be available 10 times or 100 times as well if you want to, or 1 time as well. Okay. But 3 is a very commonly accepted industry term, industry number basically. Okay, commonly accepted number. So this is about reliability. So reliability of data. And it is scalable. So what is the scalability? Now coming to the scalability part, basically we have two kind of scalabilities. One is vertical scalability and the one is horizontal scalability. Horizontal. So vertical scalability, in vertical scalability you will have a limited number of machines, 1 or 2 or 4 or 3, right? So the limited number of machines. And when you want to grow the size of the overall size of your storage system, then you will simply replace that with the bigger machine, or there are two options. You can simply replace it with bigger machine, or you can simply replace the hardware with the better disk and better RAM, right? But this approach has a limitation. That is, the maximum RAM or disk which can be used is limited to the maximum disk or RAM which can be fit into that a single machine or that set of machines, right? This is called vertical scalability. Okay, wherein you are trying to grow the size of the system. And there is another kind of scalability called horizontal scalability, wherein you have a machine and you can actually, if you want to grow the size of the system, overall system, then you can simply add the machine. You can add another machine. Either it could be a smaller machine or it could be a bigger machine or it could be whatever. And all these machines are connected over network. Okay, so we are creating a cluster of these machines. This is called horizontal scalability, and Hadoop is basically horizontally scalable, and horizontal scalability doesn't have the disadvantage of limitation. You can actually scale it to any extent. At least Hadoop can actually scale to any extent. That is about scalability. Now coming to distributed computing. What is distributed computing? So before talking about distributed computing, let us talk about distributed storage system. Hadoop distributed file system. HDFS is Hadoop distributed file system. Now distributed file system, what does it mean, right? So let me just keep it simple. So let us assume you have 100 GB of data. In Hadoop, basically, or any distributed system, would try to homogeneously divide this particular data. So let us assume we have 1 to 100 systems. Okay, this will help us to keep the calculation easy. So this 100 GB is actually divided into 1 GB the various machines. So obviously you have 100 GB in the end. Okay. So now don't worry about the replication which I have talked about. Okay. So internally again this 1 GB is replicated, and every 1 GB is, all this data is basically replicated. Okay. Don't worry about that. Now this is basically called distributed storage. And what is distributed computing? When you submit a job, to process this 100 GB, then the job is divided into subtasks, and the task will actually run on these 100 machines to process the respective data on such machines. Okay, so 1 GB on this, 1 GB on this, 1 GB on this, 1 GB. So all these 100 machines are actually working to process that 100 GB of data. So that would actually bring down the overall time to process it, right? So it can, so something which can take 2 hours can actually be brought down to 120 minutes by 100, 1.2. So this time can be brought down to 80 seconds. So that is the power of distributed computation. So we basically have 2 components. One is HDFS, called Hadoop distributed storage, Hadoop distributed file system, which deals the storage part of it. and we have a component called MapReduce, which deals with distributed computation. So this is about storage and this is about computation. So both of them are distributed and both of them obviously are scalable. So now you can see that both storage and computation problems are actually solved with Hadoop. And people who have actually researched something, you might know that MapReduce is called MRV1 basically, and there is something else called Yarn, which is called MRV2. Obviously in our class we are going to discuss all those. And now coming to the characteristics of Hadoop. So it is reliable. We know that how it is reliable. It is through replication of the data. It is scalable. We know it is horizontally scalable. And it is flexible. We talk about this flexibility. It is economical. So it is cheaper compared to the traditional storage systems. At least Cloudera, which is one of the commercial Hadoop distribution company, it says that to store 1 TB of data in RDBMS or warehouse, basically they actually spend around $30 million per annum. Sorry, $30,000 per annum per TB. That can be brought down by 10 times and it can be $3,000 per TB per year in Hadoop basically. Okay, again that if you are using a commercial distribution. Again, within Hadoop, if you are using commercial distribution of Hadoop, then it will be $3,000 per TB per year. So that is a very significant saving. And coming to flexibility, so Hadoop basically gives the flexibility of schema. So you can see a table, or you can actually create something called table in Hadoop, which we will cover in our next concept. Okay. So you can create multiple schemas on the same data set. In RDBMS it is different. You actually first create a schema and then you put the data. But here it is different. You first put the data and then you can create multiple schemas on the same data set. Okay. So it is we call it as dynamic schema. And who is using Hadoop? Of course, everyone is using Hadoop now. There is no limitation. Okay. Every damn company is actually using Hadoop. Okay, Hadoop Jungle. Why do I call Hadoop Jungle? So basically, this guy called Dow Cutting who has actually created Hadoop. He gifted a small toy to his son, and that elephant toy, basically that was an elephant toy, and that guy somehow called it as Hadoop, and he took that name from that elephant toy, and he just named this software after that. So that is why wherever you see Hadoop, you see that elephant symbol, elephant toy symbol. Now after that, these crazy guys actually started building some other components which work on Hadoop, and they are named after various animals like hive, pig, impala. Okay. So we just and there is another component like zookeeper. Zookeeper is a person who takes care of all the animals in the zoo. Right. So of course, within this we have various things. Like if you are a Java guy, then you are very good fit, and if you are a SQL guy, then you are the next. Actually, you have something called hive and pig and all this to deal with HBase. Right, and there is, if you're a scripting guy, then you have pig to deal with this unstructured data. Okay. So the various tools which are involved. Hive actually gives tabular form, basically something like SQL, right, wherein you can query and you can get the data on unstructured data. And pig is like a scripting language. It has its own scripting language called pig Latin. Again, this is also to process the unstructured data, and Scoop is to pull the data from RDBMS into Hadoop. So every tool, every component has its own use. Okay, and I'm just calling them as animals. Okay, and we are going to work on each of these ecosystem components. Each of these ecosystem components. And then coming to distributions, right? So Apache is the one which actually is licensed, this Hadoop, and Apache is, it's more than a company, it's a community, okay, wherein it actually manages all the open source technologies, and Hadoop is one such open source technology which is managed by Apache, and all these remaining guys are actually commercial distributions. What they will do is they simply take Apache Hadoop and they provide some UI and make it easy to use, okay, and they also do some integration testing along with these components, right? So these various components which are used along with the core components called HDFS and MapReduce, they are tested, compatibility is tested, and they will release their own product, and then they also provide support. Okay, they will help you if you need anything, and they will ultimately charge you for that. Okay, support. So that is a business which these guys are doing. And out of this, Cloudera, Cloudera, Artenworks, and Mapr are basically quite famous. And in our class, we are going to first start with Apache Hadoop and then move on with Cloudera, Artenworks, and Mapr. So we are going to discuss and work basically. We are going to launch all these VMs in our class, and we are going to work with them. And then coming to the next part, Hadoop on cloud. Yes, so how Hadoop and cloud are relevant, right? So cloud basically has many things like infrastructure as service, software as service, or platform as service. So basically here we are mostly interested in infrastructure as service, okay? Because Hadoop basically have, as I mentioned, hundreds and thousands of machines, right? So obviously when someone is evaluating it, they want to have at least a 15-node cluster. If not at least, I would say, and on an average, probably, at least it could be 5 as well actually, but on an average people try to use 30 node, a good amount of data, and they don't want to shell out the money on this infrastructure to buy all these machines, and so they create their machines on cloud, wherein these cloud companies, cloud vendors are actually providing this facility to create machines on the fly and delete them on the fly whenever they don't need it, right? And you can also scale these machines, like you can add RAM and disk immediately within seconds. You can do that, right? Unlike if you have a real machine, you have to procure that and then you have to scale it. All this is so basically just to avoid such things. Okay, most of the, and it is also some maintained by these companies which which actually provides that reliability. Fine. Now coming to this, so we are going to, in our class, I'm going to use Amazon EC2, which is one of the cloud vendor, okay, and which is mostly and internationally used, and we are going to create at least a 4-node cluster, 5-node cluster, and then we will install Cloudera on it and see how you can work with remote machines, and how a real environment is going to look like. Obviously your cluster of these machines will not be there just beside you, right? You are not going to connect to these machines which are there on your own network, obviously. So how you're going to connect to this remote network, remote machines basically, and how you would work with them, and all these things we are going to discuss in that part of it. That would actually give you the real-time scenario of how you're going to connect to these machines. And then coming to certifications, Cloudera, Hortonworks, and Mapr, all three are providing certification. Okay, and certification, however, is no means is the measure of your knowledge, obviously, but it helps in some other way. Okay, and Cloudera is most recognized, and then Hartenworks, and then Mapper. Yes, and Cloudera charges $295. Mapper also charges $295, and Hartenworks around $150. Okay, and for all of these guys, the number of questions is going to be close to 60 to 70, and 70% is a pass percentage. Okay. And this is just the trend which I have taken long back. I haven't changed it. Okay, but right now basically it is somewhere like this, I believe. Okay, and this is the trend of COBOL, or if someone is from mainframes, please excuse me. That is how the trend is. Okay, and this is just another slide wherein it shows that the amount of money which has to be pumped in. Okay, so this is just the number which okay, I'm sorry about highlighting that. So this is the number which in that many USD dollars, and right now we are somewhere here in the middle. There is a lot of money to be pumped in into this. So at least that's what this particular market research says. It's not me, obviously. Okay, and then yes, in the end, basically we are going to work with POCs, proof of concepts, or mini projects, which people call. Okay, and we understand how these components work together. We work with them. Okay, and then see how these components work together, and design a solution around it. And I'm going to share so I'm going to share interview questions as well with you guys. Okay, and my previous batch students keep contributing interview questions to me, and I just keep adding them to the existing database, and I share it with the latest batch. And apart from that, okay guys, and apart from that, I'm going to share this Cloudera practice questions. Okay, if you look at this particular Cloudera site, they would actually provide the practice questions wherein you can buy it for $125. I've already bought it. Okay, if you really buy it, you would only get around 60 to 70 questions, which will keep on repeating whenever you answer them. So those 60 to 70 questions, whatever they are providing, I've already copied them into PDF, and I'm going to provide that PDF with you with answers and explanation there. Okay, so you guys already have it. Okay, so I'm going to share it with you. And sample resumes, yes, and material to practice, and all these things are actually going to be shared on a mentor-mentee site called Piazza, wherein you can actually just log in wherever you are. You can just log in using internet, and you can just download the material anywhere, any place, anytime. And 37th is the latest class which is going on, and 38th is the next batch which we are going to start, as I mentioned. Let me just open it properly. Right, so okay, so I'm going to share all the material here. Okay, for every concept. And so I'm going to post, and you can ask me any questions and all. I'm going to share all this obviously with you guys, and much more. It's not yet done. Okay, so all the resumes and all whatever you have said, actually all those will be shared. Okay, certification rounds, and all this will be shared. Interview questions, resumes, everything will be shared with you, right? And okay guys, so this is a mentor-mentee site, and this is going to be there. Once I create it, it is going to be there forever. You can just download it anytime. Okay, and whenever I update new things, it will be shared with everyone. Okay, and then yeah, and coming to the more details. Give me 1 second, guys. Again. Okay, so this basically we are actually having two batches, right? We have morning as well as weekend. Morning batches. Morning it is going to be from 6 a.m. to 7:30 a.m. IST, and weekends we have at 7:30 p.m. to 10:30 p.m. IST. Okay, and the cost, the fee is going to be 350 USD, US dollars, and then the number of hours, it is going to be 40 hours, and weekend sessions are going to be for approximately from 6 to 7 weekends. This is going to be from approximately 30 classes. Okay, and this includes, obviously weekends include both Saturday and Sunday. Okay guys, if you have any questions you can raise. You can just post them in chat window and I will just answer them. Hello guys. Please post your questions in chat window. Okay, that's a good question. What is Impala? Before going into Impala, you have to understand various other components. Okay, so I assume that you already know about Hive because you asked about it. Right, so Hive is, Impala is basically faster. To keep it simple, I would say it's a faster version of Hive. Full day classes for a week? No, we don't have such thing, right? So if you have any full day class for a week, no Advait, we don't have such classes, but on request we can provide them. But for that, just you need to just mail us, then we will get back to you. So how you make us do any small life? Yes, that's a very good question. Vijan has asked a very good question. So guys, you are going to create your environment on your own laptop. So the beauty of Hadoop is it can work. It works in a very similar way as it works in a 100 node, or it works on a single machine as well. So we are going to create VMs on your own laptops, and we are going to create a cluster of Hadoop in it. Okay, and then we are going to work on that particular cluster. Okay, we are going to create Apache and all these clusters, and then we are going to work with that. Okay, so we are going to provide, one good question is what if you miss classes? So you will never miss a class because you will always have recordings of the class. Recordings will be provided and PPTs will be provided. Yes, recordings will be provided. Okay, and how to import MATLAB library into Java? Oh, it's guys. Okay, and the another question is how different is R from Hadoop basically. So R is different and Hadoop is different. Hadoop is to solve this storage problem and computation problem. R is to do analytics. okay, whatever analytic algorithms I have said, like clustering and all these parts, basically that can be done in classification, clustering, all these kind of algorithms can be actually be ran on R, but R can integrate with Hadoop. Okay, R can integrate with Hadoop. No, guys. So everything which we use is actually free of cost. So you will not buy any software. All this is free. Okay, guys, so machine learning, Mahout, someone has asked me about Mahout. Mahout is basically a machine learning tool, right, like R. So, but Mahout basically uses MapReduce to do analytic programs. And R is an external tool which is not part of Hadoop, but it can be integrated with Hadoop. So over a period of time, these various analytics tools like R, Vika, right, and various other analytics tools have provided some kind of connectors which can work with Hadoop, because they have seen that Hadoop is very good, very good at big data. So they wanted to provide some connectors. And okay, and one more question is, yes, so guys, DB database, basically you would just, it's very simple. Basically here you would, the very basics of database knowledge is enough, like tables, joins. It's a very small concepts actually. Okay, and what level of Java knowledge is required? Yes, this is a good question. So Java knowledge which is required, the core Java knowledge is more than enough. When I say now Java, I am not saying J2EE and all this stuff. Core Java is more than enough to work with Hadoop. Okay, it's a very okay. And what should be our system configuration? Okay, guys, this is another good question. So what should be the system configuration? Right. So if you can get even 2 GB RAM laptop, that is good enough. But I would recommend 4 GB RAM laptop. Okay, at least 4 GB I would recommend. But even if it is 2 GB, you can still work on it. Right? As you know, right, the speed would differ, right? So the response of the machine and all that. Yes, so we will be, so mostly this is developer oriented, and then we will also cover admin concepts as well. Okay, I am C++ professional. Can Hadoop help me in career shift? Yes, it can help you in career shift, because Hadoop is basically very new. Right? Now it is not. It's not that new, but it's still new considerably. Okay, so you can actually just claim 6 months or 1 year of experience on Hadoop, and then you can still work with Hadoop. And C, basically C++ also have a, so supported on Hadoop using something called pipes. Okay, you may have to explore that part of it. Okay, but Java is something which most of the people use, and you can, if you can claim Java knowledge, then you can make a career shift. Yes. Which is better, R or Mahout or Python? Okay, this is an interesting question, but it is mostly about analytics, right? So R, Mahout or Python. So what you are comfortable? I would suggest R, because R is something which has a very vast algorithm support, and a lot of new things are coming into R basically. Okay. And there is something called RPy2 as well, where R and Python both scripts can be ran using IPython. Okay, so of course, guys who don't know about it, don't worry about it. This is something which which for Lipisha, because they have asked specific question, but that's fine. Is Hadoop for analyst or developer? Okay, guys. So here, so basically there are a couple of rules in this. So Hadoop is for developer as well as for analyst. Okay. So that depends on what kind of profile you belong to and how you want to move into this. Okay. For developer, you will be mostly into the development. As you know, we will be working on the scripts and developing some Java programs or C or C++ programs, which depending on the company's profile again. Okay, and coming to analyst, you will be mostly working as you will be working on these components called R. Okay, and to some extent Mahout you may not prefer as an analyst, but you would better prefer R or probably MATLAB as mentioned. Again, anything, my preference would be R. Okay, so MATLAB is also very good, but my preference would be R. So analyst role is different and developer role is different. Okay, analyst is a guy who actually is very good with functional knowledge of that business. He is mostly a functional expert who also has some knowledge of analytics algorithms, and who can use one of these tools like R, MATLAB or Vika, and they can actually get better results, or they can develop better algorithms as they know business. And as an IT guy, you may not have to know about business. You will be involved in the background, wherein you will be loading these unstructured and structured data, and you will be converting it into the various forms and give it to the analyst, and then analyst will actually take care of it. Okay, so there are two different rules. Okay, now another question is, hello guys, hi. Okay, reporting tools basically. IBM Cognos is one of the reporting tool, like OBIE, like Pentaho, like Tableau. Okay, all these has Hadoop integrators which can connect to Hadoop specifically to Hive, and they can run the query on Hadoop and get the data, because Hive is very similar to SQL, which you can understand only if you see Hive. Okay, which we will highlight when we come to Hive part of it, in which inbuilt. Oh, okay. Lipisha, I'm sorry, I cannot get into this. It's for general interest. I would not get into the details of analytics. Okay. Yes, Lipisha. So R is a open source tool. Okay, and R has so all that you have to do is, the best source of knowledge is basically the R itself, R link itself. I would just say that for now, but I can just send you the links offline. Can you send me this recorded video? Yes, guys. So this recorded video will be sent to you. Guys, you have any other questions? Okay, thanks guys. So this is the information. Can a person that is not familiar with any programming language learn about Hadoop? I would suggest you to have at least one programming language knowledge. Okay, at least SQL, probably PL SQL. Right? Somewhere you know the basic constructs basically. Right? So what a loop is, what if condition is, right? If you know such things, then I believe anyone can actually learn any of the programming language with some effort. Yes, Vijay, so right now you cannot send me the questions directly. You have to mail them to which ID, right? So that is the question. You have to send them to, let me just provide you the details. Yes.
So I'm going to give a little background here first, just as a context.
So guys, I have just sent you the details. So you can just reach us on any of these. You can directly call us, or you can also mail us. Okay, guys. So you'll also be followed up with a mail, and just if you have any questions, you can just come back, right? And we will be happy to answer your questions, right? So if you don't have any other question, then I have this final question. So are we ready? Right. So just think about this and then get back to us. Okay. Thanks, guys, and thank you very much for your time and for your interest, and thank you very much for attending this demonstration, and I hope it helped you in some or other way, and I hope you have spent your time learning something. Thanks, guys. Thank you for your nice comments. See you guys in class then. Thank you very much.